right, gonna get started here in a minute. I've got nothing on my screen because I haven't made my notes yet, so we're gonna make the notes real quick, and I'm gonna figure out what I'm gonna do today. But it's gonna be probably another day working on the Nordic radio stuff. I also had uh, Justice. I think I'm saying that name correctly. No, the music stopped. Well, yeah. By the way, the music is Louis Zong. His name's in the description of the video, but he made this awesome statement on Twitter that was basically like, any of my music, you can use it in whatever as long as you cite me. So if you're streaming or whatever, if you're using it for like a short or something like that, as long as you're not a giant company, feel free to use it as long as you cite me. So I went and bought all of his music, which is like 100 EPs on Bandcamp, and so I've been using that for all of my streams so far, and I probably will for a long time because it's good chill music and it's awesome background. So I'm just like rotating through all of the 100 EPs, like unzipping one at a time or a couple at a time before each stream. So if you're wondering what the music is, that's Louis Zong. You should definitely check him out. He's also really awesome on Twitter. He's also an animator and does a bunch of stuff. But I'm getting off track here, so let's go ahead and clean up my notes and figure out what I'm going to do today. So Justice, I have to admit, the first couple times, because your handle on chat is like Justice C, and for a long time I thought it was a like clever play on words of like just a sec, like it'll be just a second. But no, then I realized it's your actual name, which is still pretty cool. But not what I thought it was going to be. So let's see. I think we probably have. See, I have two people who said I was going to do stuff. So plan topics. I'm actually going to go look at what I'm probably going to do is probably look at Justice's repo real quick, because he's been having some questions about how to use BBQ. So I'm going to look at that first, and if it goes really long, then I'm going to come back and spend more time on it later. But I'm gonna go try and find. Okay, that's right. You put in a link to the gist in my office hours slash James Munn slash office hours. Let's rip this tab off and move it up to the streaming screen. So as a reminder, I got all my notes here. So if you're ever looking for like what I did or notes from a stream or links to stuff, or if you want to request me to talk about something, feel free to open an issue or whatever. I'm also hanging out in the Matrix chat. There's a link to the Matrix chat here. Yeah, you can listen to me make terrible song jokes, plug a bunch of streams. Let's go ahead and pull this handle grant release from an ISR. Okay, so let's go look here, and then let's open this gist. This is actually super relevant because it's basically what I'm going to be doing today for the Nordic stuff, because I'm writing a driver for that. Apparently it's also just Ace. Okay. So let's see, you've got some stuff. You're using RTFM, so let's full screen this. So you've got your producer and consumer and grants. That makes sense. Let's see, in the init, and you've got your BBQs up in static. That makes sense. As a note, if you watched the stream from yesterday, I always put ridiculously long names on these, especially when you have two buffers going in opposite directions. I always have like receipt. Don't apologize for the code. Let's see. Oh, getting emails. Like I said, US clients start emailing me at what is 10:45 my time. But okay, so you probably do a split of the BBQs. So you have an initial receive grant. Okay, so you do grant 32. And then, yep, so you've got no grants active except for the receive write grant. Okay. Idle's doing nothing, so that's cool. Where do you use, what's this called? Receive write grant. Where else do you use this? Okay, so you have this task, spy complete. This function is called when the spy master stops talking to the slave and sets the NSS line high. This function will then call the process command function. So this happens when the spy is complete. Store the stream instead of the full DMA device. Been bad. Okay. So you might check out the issue for a description of the code. Yeah, I was just about to start asking you questions about it. Okay, so let's place 8 state variables and resources to maintain all things. Yep, makes sense. Establish, you know what, let's rip this out and let's establish the spy device as a slave, lines 113, split out each of the prod cons pairs. Yep. Generate grant from the RX producer. Set up 2 DMA streams, one for spy RX and one TX. Enable the DMA RX stream. Store all the states of the BBQ objects in the late resources instance. The resources elements are the producers and consumers for each of these RX and TX channels, in addition to holding the active grants for each of these. The grants were not stored in there previously, but we found after some discussion that they needed to be in there in order to communicate between different functions in the RTFM framework. They are implemented as option, and they are none to begin with the exception of the initial RX producer grant W. Spy set to spy state. Data is received and piped in by the DMA. The spy complete function is called when the select line goes high via the ISR. Okay. The process command function extracts the data from the RX buffer, processes the desired command, in this case just an echo. The process command function requests a TX grant to place the return data and copies the return data into the buffer. The process command function then creates a TX grant R and passes the buffer to the DMA. The process command function then enables the DMA line. SpyMaster then requests n bytes of data because it knows how much to ask for based on the protocol. The spy complete function is called when it goes high. You have SS line goes high twice. So is it actually like 2 split commands? So like it sends you data, then the line goes low, then it waits a while, then it sends the line high, and then you pump data back? Is that how this works? Because it knows how much to ask for based on protocol. Spy function is called when the select line goes high. Resets the state and clears things out for the next comms request from the master. Also, I did not put it in there, but at the beginning of the process command function, one of the GPIO pins is set high, indicating the spy master the MCU is busy processing a request. Okay, so yeah, he's saying that yes, that's how that works. At the end of the process command function, the GPIO is set low. The spy master waits in this line to go low to problem discussion. Yeah, you really don't have to worry about efficiency. Like the overhead of these resources is like nothing. So I mean, they're just the same as having like a static variable. So it's really not a big deal. The more interesting question is, do you need access to both the read and write data at the same time, but it seems like you have like a 4-state state machine. So states of the ISR. You basically have idle, ready to receive. You have received data. You have ready to send. I guess receive data, waiting to send. I guess you have idle, receiving data, receive data, waiting to send, sending data, data sent back to idle. So I think these are roughly your states. And then what you have is essentially like each of these states are just a linear state machine in that I would have thought the ISR only had 2 states. So how many times does this ISR, I guess, gets called? What gets called when the DMA is completed? So I mean, like this may be multiple states of your machine. You have like idle. This is like SS pin goes high. Only gets called when SPI transactions are done. Okay, so this is actually like the SPI. There's nothing called when DMA is completed. Really? There's no like, I'm not super familiar with the STM32. I thought usually they have some kind of event or interrupt or status register or something that happens when the DMA completes, but I guess when DMA is completed. Never polled. Where did I see busy? Okay, so there's process command. What triggers process command? Spawn process command. Okay. So you're going to process the command, and then when the command is processed, it goes low, and the other device is receive grant. Okay, so let me go back. You are going to receive data, process command, begin response, complete, receive / process command. complete response go to 1. Excuse me. So spy complete fires every time the transaction has finished. And process command is just a task. But 1 and 3 never happen in this function, as this is only called when the SS line goes high. Wait. So you just like every time the line goes, like the line going high is actually line goes high every time. Okay, so what I'd probably do is I probably wouldn't store the grants in resources. 1 and 3 only happen in hardware. Yeah, that's fair. That's fair. Okay, what I'd probably do, and I don't have a full working version of your code, so I can't really compile it. SS is normal high. Wait, but it goes high. Wait, I'm confused. The function is called spy, stops talking to the slave and sets the NSS high line. Okay. Function will call. Oh, okay, gotcha. So it's actually being called like after the steps or something like that. Okay, so I'm going to make some suggestions of what I would do. I would not have the grants in. So I believe you only need the grants here. Yeah, because you need. No. Incoming grant. Yeah. Yeah, okay. I'll take the whole file. All right, I'll make up a project. I super recommend making new repos and like just make a repo on GitHub, because like on a gist it's super hard because I have to go and make a new project for you, and like I don't have the .cargo config and stuff like that. So like making a full repo instead of just a gist, for the record, is way helpful. But no worries. Cargo new bin justice cd justice. So let's go take the main, and we will copy all of this. Yep. Okay. Let's see if this will actually build. Yeah, what it is, I don't think you actually need to store the grants and resources. I think what you're probably going to end up having. Oh goodness, core intrinsics, panic abort. All right, let's reset. Didn't match. Yeah, I see. I think the important thing is each of those functions only sees half of the grants. They don't actually see all of the grants. This is probably like ridiculously tiny to see on the screen. Because the grants are local. As long as the actual storage buffer is static, then you're fine. But let's play around with this a bit. I think we can get this fixed, and I don't think you actually need the feature that I added, but can't hurt. There's no reason. Well, there were some reasons why it didn't exist, but I don't think it's significantly worse off as it is, and it's more flexible because someday someone might actually need that. But let's. I can't promise to give you a totally working thing, but yeah. Someone says there's something. Oh, Windows GUI. Interesting. Um. Oh, unresolved import RTFM. Are we pulling in multiple? We don't really need. We don't need semi-hosting. Semi-hosting is. Are you? Um. What am I looking for? For stream too tiny. I'm gonna steal some stuff from my main projects, and this is gonna make everything take all the time to build again. Semi-hosting is not really bad. There's just better solutions. Like it's nice. It's portability. It's super good when you're like first bringing up a piece of software, but it's like sort of annoying to work with. I tend to not use it, but um, yeah, I don't know. I don't hate it, but I don't use it. Um, I'm a little worried about that RTFM version thing, but hey, what are you gonna do? Yeah, super recommend making a GitHub repo that builds so someone else can just clone it. Oh, interesting. Oh, if you haven't watched it, you should definitely go check. You should definitely go check out. Jonas did a stream earlier today, and Alexei is actually doing another stream about IDs and Rust Analyzer tomorrow morning Berlin time. It's like 10 hours from now. So definitely check it out. I have email alerts on a lot of stuff, and I just saw there was a Register article about that, which is pretty awesome. What do you want from me? Takes one dot unwrap dot release. How many are you gonna release? Okay, I mean it's gonna be it's gonna be all of them. 391. I don't know, 32. That's a good number. And then I don't know what this psych count. Oh no. Option, which is not implement borrowing options, read grant.asref. Okay. So is this compiling for you? Is there something weird that like, or is this just like a uh as mute probably? Yeah, if you have timing critical stuff, semi-hosting is bad. Assignment to borrow. Cannot aspo 391 as mute. Move occurs. Cannot borrow. Write grant. There's some like RTFM macro shenanigans going on here. Transmit read grant. Cannot move out of. Oh yeah, I mean you actually. I know what you need to do. You need to do and then you need to do x dot read grant dot unwrap dot release. Was it for mutable reference? What is the there is like a swap ref or something like that. Core option. Come on, you definitely have a swap. Contains as ref, as mute, as pinned ref. Mute CX. Oh, is that what it is? Yeah, that's probably it. Thank you, Talus. Cannot, no method swap. Okay, what if I go back and just make that mutable? Still don't think it's gonna like it because it's a reference and it's not gonna let me release it. But yeah, like we have to let x equals none. Is that how that works? Expected mutable reference mute. Expected and mute. Just compiled the code and it compiled clean with the exception of the release line. Well, I mean, I'm not using a weird compiler. Cannot borrow as mutable 338. Yeah, because like the commit's going to take ownership of this, so you only get references of it through resources. Although I think actually Rust might be smart enough to allow that. I probably screwed something very, very simple up, and I'm making myself look very silly. write grant cannot borrow is mutable. Cannot move out of a shared reference. Cannot borrow as mutable. First mutable borrow occurs here. Second mutable borrow occurs here. Okay. Well, you are on the fly trying to correct somebody's code. You're doing pretty good code with no prep time. Good, I would say. Okay. I'm not following. But to be honest, I don't actually want to be doing this. So actually, let's just, I might get some of your code wrong, but let's see if I can get this mostly right. Okay, so what I would suggest is I would suggest that you have a, let's start with process spy. And we're going to do some stuff. Spy complete. So you're going to have an enum called state, which is going to be receiving let's say idle, receiving, which is going to be a grant r static u64. Sending is a, that's going to be a grant w. You're going to sending, which is a grant r static u64. And then you're going to have static. It's not going to like this. Because that's all in a macro, and it's going to do spy state, and then you're going to have enum com state, which is maybe going to be the same. I'm not 100% sure yet. Static mute spy state, state is spy state equals idle. Yo, it's moving that var into the match and you're trying to operate on the bound var. Yeah, there's some like shenanigans there, Will. But to be honest, like it's because it's matching on it and unwrapping it at the same time, but also the commit command takes ownership of it. So there's just like a couple things to unwrap here. But what I'm actually going to do is I'm going to end up having a static variable here with an enum, because each command is only doing one thing at a time. And I'm just going to make a really simple state machine that just walks through the states where you keep the grants local. And then you just like always consume the state variable and replace it with something else. So we're going to do some stuff. I think this is sort of like your CX resources spy state, but I'm going to do a different one where I'm going to do match state, where I have, oh, did I also call it spy state? Awesome. I'm very original. James spy state, because I'm special. Match state. Idle. We need to move to the receiving. You have receiving grant. We just finished receiving. Start sending. What was the other state that I called? Receiving, sending. Okay. Sending Grant. Oh, it's going to be sad about me moving. Well, static state. Yeah, there's gonna be how you commit this because I need to like swap state in the match statement. Ugh. This is the one thing that makes me upset when I'm using match statements for state machines is like I want to be able to consume self inside of the state machine. Like I want to do like SAR state equals match state, and I don't think this is like, because if I just do this, then it's still going to be upset at me because it's like, hey, you're moving out of. Okay, I'm going to start. Just commenting stuff out. Receive. Oh, okay, that's nice. 367. Okay, we no longer have the grants. $291. $340. Let's just, hack and slash. Until the code compiles. Oh, I've done something terrible. Working with statics is the worst. Oh, I actually know how I'm going to do that. That's okay. Sorry for everyone watching on stream. I need some more of my terminal. Okay, let's spy state, wait for command. 401. Sometimes you get on stream and you're really impressive and you're really doing things well, and then other times you get on and like, everything's terrible. Let's not be lazy with match statements. Use spy state. Did I get rid of a spy state enum? Have I? Oh, did I rename the wrong one? Oops. That would, that would cause problems. Yeah, that's. Oof. Helps if you are not being. Okay, so now we're at. Ooh. Oh, right. I'm not going to have. The other thing that you didn't give me is the device.x and the .cargo config. So let's stream to /tiny nrf52.cargo. Okay, and well, I guess the device.x is probably provided by your HAL, probably. But let's figure out basic state machines before I try and bite off something more complicated. So let's do let mut x equals nah, it's my code won't run, and I don't have your board anyway. I've given it enough that it should build ish. Come on. But yeah, the goal is basically that you keep the grants here because you're only ever going to have a read grant active or a write grant active. So you're just going to use like a state machine enum to swap in between like receiving mode, and then whenever you're done receiving, so this is going to go something like commit write grant, obtain read grant, start DMA. And then so this is going to be something like obtain write grant, obtain or start DMA. And then whenever you're done sending, we just finished sending, start receiving. So you're gonna commit read grant, obtain write grant, start DMA, and then this is actually going to be go to sending, and this one's actually going to be go to receiving, and this one's going to be go to receiving. But then how does process command function work? We'll get to that. It's going to be the opposite, right? Because it's just you need access to the buffer, but you're sending the buffer across. Like that's the whole point of BBQ, is that you send it from one side to another. So by committing the buffer, you're giving access to the other side. So when you commit it here, you receive it over here. So it's like a pipe between process or from SPI complete to process command. Or are you saying that you are also sending it to the application? Like, are you broadcasting it to the... Well, no, you're not. Process command's your only other thing. So yeah, you in process command, you need access to the buffer, but that's what BBQ does. When you commit it, it means that... So like in SPI complete, getting the right grant means SPI complete has access to this buffer. Or by obtaining the right grant, SPI now has access to the buffer. But when you commit it, now process command has access to the same buffer. Okay, no. Apparently that is incorrect. So, no, correct. Okay. So yeah, process command needs access to it. So I mean, like, you have basically, and then when process command wants to respond, it's going to shove stuff in the buffer that goes the other direction, and when it commits that, then SPI complete is going to have access to it. So then you have access to the same buffer. Like, it's the same buffer. Well, it's two different buffers, but like the two interrupts are working with the same two buffers, but they get access to the same data, and that's also what you're DMAing out. So let me, now that this, you should ignore the no. Okay. Okay, I am still going to steal the memory.x. That's fine. This is going to be memory.x. works. This is super not right for your target, but it's enough that it'll work for compilation. Cannot find tlink.x. Yeah. Oh, it helps if I okay. So what we're gonna do here now. Okay, so I've swapped temporarily swap. And then we're gonna do actually star state equals match state match x. So stop both of the DMA channels. Cool. Commit the grant. So we are waiting for command. So receiving. So when we were receiving, we just finished receiving. So yes, we want to commit 32 as usize. Receive process command. Okay, so then we spawn the process command. Okay, but the write grant actually, okay, there's one more state that I need. At this point, the return data has been transmitted and we need to, oh, is the DMA getting triggered? Set the SPI state to return data. Okay. Okay. Now I'm sorry, I was disagreeing with you so vehemently. Now I'm understanding that you're kicking off the DMA in two different. Oh, that's interesting. Well, now I'm just confused at everything that's going on here. But that's pretty much how DMA works. So no, I mean, like, I don't. There's probably a more elegant way to arrange. Like, I don't think what you have is like totally wrong. But I'm also working on understanding it. So I'll admit that I'm not totally understanding, because right now you have the process command. This actually, let me go read. What I probably should have done is probably process command function extracts the data from the RX buffer, processes the desired command. So in that case, I am doing that. To place the return data and copies in the buffer, the process command function then creates a txgrant r and passes the buffer to the DMA. Yeah, that's cool. SPI complete function is called when the SS line goes high. This is the grant. So, I mean, no, I mean, it's fine. It's an interesting problem for sure. So I mean, the thing that's kind of confusing me is SPY complete gets called when the when the pin goes high, so when it gets unselected. So I need to have a think. I need to have a think. Where are my notes? Notes. Okay. I'm gonna think. And if I come up with yeah, firmware is already always reactive. Okay. So you have to do you start the DMA when the data is ready to go out? Okay. Buffer set up. DMA ready to go. DMA writes. SS goes low. DMA fills buffer. Fills buffer. SS goes high. SPY complete is called. SPY complete releases buffer. Pens process command. Process command. So this is the part that I'm not super understanding. So I think I've understood 1 through 4 so far. So process command does some thinking, prepares a response. And then puts it in buffer, starts DMA, like makes DMA ready to go. And then the and then SS goes low. DMA drains buffer. DMA drains buffer. SS goes high. SPY complete is called. Like, I understand that there's two. I understand how you have it designed right now, but like, I mean, okay, speaking very honestly, when you have a strict when you have a strict command response thing like this, I don't actually know if BBQ is the best solution for this, because like if you're doing a bunch of other complex things in your application, then that might make sense. BBQ is nice for like buffering messages so that like there's always a buffer ready to go when you're right. If you have a strict like command response, like you could just have a function that was like I'm thinking like a ping pong buffer or something like that, that like when it's complete, like something like init prepare DMA mark ready, then basically like SPY complete would read DMA prepare or SPY complete would mark busy, read DMA, prepare response, prepare DMA, unmark busy, and then just go on with its life. I may have made a terrible suggestion to you that you should use BBQ, but like I could see you totally getting away with like a single buffer hanging out in resources, like this buffer that is shared. When you have like a strict command response architecture like this, when you're not like servicing other stuff while this is happening, like if you had some other task, like if you had something like over here in main hanging out and doing stuff and like waiting for incoming commands, then it might make sense, because like you have kind of asynchronous send response, like so like in Vintage, I have USB packets that are going on all the time, and I have, although I think I'm not using heapless here, I'm using SPSEQ, but it's going to work about the same way. But yeah, I have like Where's my resources? Here's resources. So I have USB channels and client channels where like these are the two halves where essentially like you have the half that you give to USB and the half that you give to your application. And like when you want to send messages back, you do it that way. And when you want to send messages the other way, you do that. Yeah, I'm going to keep thinking about this. Like at least looking at the problem abstractly, I actually feel like BBQ might not be the best approach if you have like such a like whenever you are given a spy command, you need to immediately respond to it kind of thing. But I mean, I guess if you have like if this ends up being a really long function or like requires you to block and do a bunch of other stuff like, oh, I'm going to go read an I2C sensor, which might take a long time, then it might work for that. But yeah, I'm going to keep thinking on this. Apologies that I probably made a lot of suggestions that don't seem to have helped. I'm still wrapping my head around this. So I appreciate you writing it up. That like you're now that I've read the code and this a couple times, this makes more sense. But yeah. I mean, as a note about how much to free, if you're not sure how much to free, there's BBQ does have a framed mode where you can set how much you used. You set how much you use, so like it's actually encoded to the size of the grant. So yeah, if you like need to know how long the messages are, framed is good for that because basically you get a special version of the consumer and the producer where the producer, you tell it how much you want, and then when you commit it, you tell it how many you committed. So yeah, you'll get a frame grant that when you commit, you say how many you used. But then on the consumer side, you don't tell it how many to read, you just get a read grant. And you don't have to tell it how many to release because it always releases one frame at a time. So like if your incoming command was like 23, then your receiver would always get a 23 byte grant. Even if there was like 5 messages in a row, you would just get like the size at a time. Having the ability to handle long commands, BBQ might work. Yeah, I'm gonna go off and work on BBQ for some other stuff, and maybe it'll be more clear. You'll see what I had in mind, but like, yeah, you might be better off with like instead of just a buffer, you can have like a heapless. See, I mean, like the thing about BBQ is good when you have multiple messages that can come in a row. If you just have one message and you're always only ever processing one message in parallel, and you can't be processing any other messages before you respond, then like something like heapless vec might be really good because heapless vec you can do things like push into it or extend it or things like that. Like when you are only processing one response at a time, you don't really need BBQ. BBQ is for like shoving queues of messages. Like if you have a radio and you say here are the next 6 packets to go out, go work on it. And like the radio asynchronously drains the buffer. BBQ is really good for that, where your application could shove in like 9 messages at a time that are of variable size, and BBQ can just go and sit and drain the buffer. Or if you have a serial port where you're logging, and logging is much slower to drain than so Talis, they are checking the DMA buffer for this. But they're not putting it in a framed message. I think this is what Justice needs, at least to figure out how many bytes they used. I think Justice needs to use the framed version if they're using BBQ. But like I said, if you have like a UART where you're like one log message is 12 bytes, one log message is 15 bytes, where you like BBQ's usage profile is something like a UART where you might do something like push 12 bytes, push 57 bytes, push 33 bytes. And then like the other side might do something like read less than or equal to 64 bytes. So then like when you're doing a DMA over the serial port, you say, give me the next 64 bytes, send it. And then you'll do another like read less than 64 bytes. Or like for like a radio where you might do something like push packet, and you just do that like a bunch of times in a row, and like these all get pushed very quickly because maybe you have like a bunch of outgoing messages, and then like relatively slowly pop packet, and then like this is, you know, moving at a much slower rate where like you push in a bursty way but then you pop like very slowly or something like that. BBQ is great for that when you're queuing up multiple messages, but you have a very, at least the way your code is today, it might change in the future depending on what your use case is, you have a very like command response kind of architecture, which can actually be much simpler than both of these. Like these are asynchronous use cases where you have a very synchronous use case where you receive one message, you do something with it, you respond it. There's no like you receive a variable number and then you respond a variable number like asynchronously. So actually I think you can make, honestly I think you can make your code much simpler than BBQ using something like heapless vec, where you can have like a U8 and you push into it to a variable length, and you can always get a slice of it. So you can always like get the slice and give that to your DMA. And then once you're done with DMA, you just clear the vec, like vec clear, and that zeroes out all of the things in the vec. And just have like one buffer for ingoing and outgoing. So like, honestly, if you can keep your application to command response, that's almost always going to be a much simpler architecture. You don't need multiple tasks and stuff like that. You really just need like, where's that sequence that I came up with? Like, you have like, this is totally sequential. So like sequential. So in init, you just prepare the DMA once, and then DMA complete is literally always this. Like, you don't even need to call another task or anything like that. You just do everything like no state machine. You can write very like linear code. Like you just mark the GPIO as busy. You read from the DMA. You call a function. It doesn't even have to be a separate RTFM task. You can just call a function. And then when the function is done, you prepare read incoming DMA, prepare outgoing DMA, unmark busy. And yeah, I guess you might need like another one that does toggle in between these two, because yeah, you're gonna have like, I guess this is when idle. Yeah, you're gonna ping pong back and forth between like when done sending, which I think is actually, now that I'm looking at it, it's totally what your state machine already is today. Yeah, when done sending, you just, like when you're done sending again, then you just prepare incoming DMA, mark busy, prepare outgoing DMA, unmark busy. You just prepare incoming DMA, where yeah, you just have like a little toggle back and forth. Like, I guess this is what you have. What I'm saying is you don't need BBQ in another task for that at all. You need like one static buffer. Well, I guess it can't be static. I guess it has to be a resource because you have to init it in idle. Or I guess you have to init. Yeah, but you can put that in resources. What I would do is I would put, if I were you, now with my understanding of what I have, what I understand now, which still may be wrong, I would put a heapless vec in your resources, shared in spy complete. I would not make process command a task. I would just make it a function and pass a reference to the vec to that, or maybe like have an incoming vec and an outgoing vec. Maybe if you want to do it like zero copy, if like it's usually going to be the same command structure, you can just mutate the same vec. And I would just pass a mutable reference to the vec to process command. And yeah, and just have like a boolean, maybe an enum that doesn't contain any state or anything like that. And just have like, you can have a static enum inside of the function, um, kind of like I did here. Like just have a real simple like, um, yeah, just like a real simple like, which again, this, I think this is mostly what you have. And then just in function, you'd have something like static mut state. Oh yeah, you need like when receiving. No, I guess yeah, state. Okay, yeah. And again, I realize this is like totally what you already have. Um, yeah. So yeah, I think you actually like. I think your structure is actually almost totally there, but I don't think you need BBQ for this. Honestly, for a strict like command response, I would switch to putting like one single or one incoming and one outgoing heapless vec in your resources, and like call it done. And you don't need two tasks for this. You can just like, your task can just call a regular Rust function and just hand it like a mutable reference to the vec, or like handed a mutable reference to the so like um receiving and like prepare a response is just going to be something like process command and mute cx.resources dot my vec, or like incoming vec and mut cx.resources dot outgoing vec. Um, yeah, and what you'd probably, for like the preparing DMA, what you'd probably do is like, heapless has like a set length field, so you'd set it to like the maximum length of the field, and then when you have when you actually finish the DMA, you'll need to like get the yeah get the size, and then you'll like, I think there's a truncate method on the vec, so you'd like truncate it to there, so you'd like fill it back out to 0 and then you truncate it back to what it was. Otherwise you could just do this with a plain slice, honestly, and just like you could pass in something like incoming slice rx bytes or something like that. Like you could just do this, like you probably don't even need a vec. You could just have literally like a slice that sits in static. But yeah, I think this is basically what you're gonna want, at least if you have a strict command response kind of system. So sorry that was a very long answer, but yeah, it's worth looking at like the architecture of that, and sorry for going a little like overexcited. I was very focused on the BBQ versus like, okay, what are we actually trying to do here? So hopefully that was helpful. I am gonna go take a break now because we have been going for like an hour and a half, and I probably only have like another hour in me. But I'm gonna try and work on I'm gonna work on some radio stuff and hopefully move things forward for Talus. So I'll be back in like 5 or 10 minutes. Thanks everyone for watching. All right, we got like 45 minutes, maybe an hour. Let's pop some tabs off the frame. Um, let's save this. All right. Close some of this. Let's see what you've changed, Talus. So, you know what? Let's not look at this. Let's just look at the clean commits, because I just, what? So I just want to see what you've changed. Okay, so you've gotten rid of the buffers. Some fast ramp up. Transmit has moved. Okay, let's realign that. Change to BBQ's grant. Prepare for RX buff. Yeah, tell us if you're watching. If you're, well, yeah, never mind. Microseconds. Okay. Packet. Excuse me. Okay, that's reasonable. Okay, well, I'm going to go back to plumbing BBQ. I'm probably going to get it building in the side branch, and then I'm going to try and clean up the merge conflicts, because there will be merge conflicts, but hopefully the way that you've done it should make it pretty straightforward for me. So, tell us if you think it's a terrible idea for me to just keep working on the old branch, or the old base. Let me know. Otherwise, I'm going to keep working on that. Okay, so let's move this over here. Cargo watch, resx check. No, TX buff. I know I left a comment to myself. Might have done it in the pull requests. I think that's the idea, yeah. Okay, cool. Let's see, how can I want to keep playing music because I want to listen to music. Okay, you can't hear that. Cool. So I can have background for music for myself, but you don't have to listen to me talk over music. But yeah. Where did I leave off? I had a pull request, and I had a comment to myself that I needed to fix a couple things. So actually, let's move this over here. Someone's excited. Yay. We wanted to reorganize this, so all the software use parts at the beginning. Yeah, we're gonna do that. Sort of gave up here. Oh, okay, cool. I I think ESB radio should have 2-option grant so it can own the grants and take care of committing. The ESB IRQ would pass the grants to the radio at the correct time but wouldn't hold on to them because only the radio knows. But wouldn't hold on to them because only the radio knows when it's okay to access them because DMA. Yeah. Yeah, I think we could do the same trick that I was trying to do, but that would require a static. And that gets gnarly. So yeah. Maybe I'll finish the grant wrappers first, and then I'll do a rebase. Just because like it doesn't compile now, and trying to figure out if I've rebased correctly when it doesn't even compile is going to be a nightmare. So I want to at least get it to a point where it like is sort of right, so that I know what I should rebase to. And I should probably not call this module James anymore. Let's. So this is one of those where like I feel like the right answer is like a packed struct here because like it's gonna have the 3 bytes or something like Saturday or something like that. But I guess I could just have a struct payload header length is a U8, bid no ACK is a U8, and RSI is a U8, and a pipe is a U8. U8, and then I'm just gonna impl there's 5 things. 1, 2, no, there's 4 things. Okay. Impl payload header. So the danger of listening to music is it makes me feel okay not talking about things. Bytes. You probably want to put the RSSI and pipe in the beginning if you're going with packed or something. No, I mean like I'm not actually going to packed. I'm going to use 2 bytes and from bytes, and yeah, you probably could. There's probably more efficient ways to do this, but we're going to hope that the optimizer figures that out for us, and if not, then we'll come back and fix it later. There's also, I think, there's some struct that's useful, or some library that's useful for this, but this is going to work for now. Where's... Okay, you know what? We're going to... I don't want warnings right now. I will want them later, but... Unused imports. Probably like dead code. Yeah, whatever. 0 copy. Yeah, that's probably what I'm looking for. But yeah. TX payload W. (117) peripherals 117. Okay, that's fine. Let's just take a. I'm still warming up. I don't even remember where I left off, so we're gonna. View raw access bounds checking. Grant is raw grant. Let's go look at peripherals. 117. Payload W. Okay. Oh, I need to fix this too. Byte length pid note. You said 2 bytes has the wrong order though. Length is the first, 0th byte. PID-NOAC is the second byte. RSSI is the third, and pipe is the third. Oh, but it's not in the order that the DMA expects it. Okay, length, PID-NOAC. Right, so these actually need to be before, don't they? These need to be something like. Thank you. That would have been maddening. So this needs to be RSI and pipe and. This stream has to be weird for some other people watching because it's just me like talking to my computer. What are you complaining about here? Length. All right. So I think that's maybe right. type, whatever. Similarly, payload W. Peripherals 117, payload W. TX Life. Where is... Have I not done any of the stuff where... Okay, I haven't given any of the grants to the radio or anything yet. Or I guess, no, I'm not using radio anymore, am I? I'm entirely lost. This is what I get for walking away from code. Right, because we're not using... We are still using ESB radio, but radio is just... Transmit packet and set up interrupts. The error is from the old code. Just delete it. Well, but I mean, like, I don't think I have any of the transmit stuff. ESB radio. Okay, ESB radio is... Am I using ESB radio in here? Yeah, I'm still using ESB radio. I mean, because you convinced me yesterday to not copy and paste your code, and to well, yeah, let's comment this out for now. $157. I'm not entirely sure that we're going to have the header can't leak private type. Okay, yeah. Delete stuff until if ACK. Okay, cool. If you say so, Tylus, you seem to know what's going on better than I do. So, okay, when we're transmitting, we know the header ahead of time. When we... Okay. Yeah, okay. Hey, Snarky Boojum. New to my channel, picked up an STM-F3 discovery board. Thanks for Gene Generous with your time. No worries. Yeah, this is my, like... I realized that I'm actually way more productive when I'm streaming because I don't just sit there and browse Twitter. And if you follow me on Twitter, then you would know that I'm very active on Twitter. And by doing this, I feel bad if I'm just sitting here browsing Twitter. So this at least, like, keeps my face in the code, even though if I occasionally go off on random rants or go way deep in a hole. So this is like me keeping myself honest on stuff like this. But yeah, thanks for watching. Yeah, okay, you know what? Let's go do the other thing, because we know that we're going to have to do that, definitely. And that is, the ESB IRQ is definitely going to have a grant. I'm trying to think. You can't be sending and receiving at the same time, can you? I mean, like, would it make sense to just have, like, one enum. So Talus, I guess our options are we can either have out grant and in grant, where these are both like option grant. Or we could have an enum state or something like that that's like sending grant, receiving grant, idle. Because then we don't have to pay for multiple options and stuff like that. This will end up being like 5. Well, I don't know how big a grant is. Grant's going to be like a couple bytes, but it's going to be 1 byte addition to that. I think I'm actually going to do this because like the radio really can't be DMAing in both directions at the same time. So why hold on to more data than we need? So actually I'm probably going to use something like this. So this is going to be, I guess yell at me if this is wrong, Talus, but enum radio state, because I think this is all will also be useful for you're right, we need both because we may need to retransmit. Can I? No, I can't drop the grant. Well, you know what? That's not actually totally true, Talus. So Talus said you need 2 because we need to hold on to the TX grant in case we need to retransmit. But if you drop a grant without committing it, the next time you ask for a grant, you'll get the same grant back. Can I use that without having to hold on to the grant for multiple times? Does that actually help me? I don't know if that actually helps me. I'm going to go with this for right now. So I guess you need 2 because we need to hold on to the TX grant in case we need to retransmit. So I need to send. Yeah. Okay, I'm trying to prematurely optimize. So no, you're right. Let's not do that right now. Let's take the options. I think I could get away with only having 1 at a time, but then I'd have to do something tricky like commit when I get the ACK or something like that, and I know I'm gonna end up shooting myself in the foot. So let's just I need TX grant, which is going to be an option. I still think we need an enum for this, but yeah. Option. I guess we already have a state. I wonder how much of this I can move into state. Who names enum state, honestly? Oh, probably me. Where am I? There's this. TX grade is going to be option. Is it better to put it on the ESB radio? Well, I mean the radio, the whole IRQ is going to be there in the IRQ, so I don't think it matters too much. Like it could end up being on the ESB radio. I guess, yeah, you're probably right, because otherwise I'm going to end up having to hand it in, aren't I, every time. Well, that's not helpful. I don't know why you're watching my stream. I'm just like doing what Talus says. So I mean, you should probably just follow Talus, and Talus, you should start streaming. How's your do you have good Wi-Fi there? See, this is the secret. This is the secret of Ferris Systems. Is I'm actually the worst developer at the company. So, whenever you come to Ferris Systems, you definitely want to talk to like Jonas or Alexei or Jorge or someone like that. I'm like, I sneakily do some of the business stuff and pretend to be able to program, but like you should probably talk to them because like 90% of the time I'm asking them for things. So the trick is to surround yourself with way smarter people. Safer the way that you avoid using it. Yeah, you surround yourself with people who are way smarter than you. It's good to be the dumbest person in the room. And that's definitely the case at Ferris. Okay, let's go make a fake payload R. Tell us. Oh no, I think that's still fine. Yeah, I'm up for Zoom. I don't know if my poor little laptop is going to be able to handle Zoom and YouTube, but we can also, I think, stream. Well, no, we used to have we don't have an active webinar license right now, which is how we did the other things on Zoom, but we can figure it out. I'm up to try, and if the stream just dies, then yeah, we'll go back to chat. That's the other thing here. Frame grant R. Frame grant R, and then I did name that RX payload. Yeah, TX payload, RX payload. No, it's payload W and payload. TX is going to be a payload read, and RX grant is going to be a payload write. Can YouTube have guests? Otherwise, I can pipe your voice. I could pipe your voice into YouTube. That would probably work. Now I need to do all of the type argument stuff. Because now my radio needs to be generic. It'll be some real pair programming. Unexpected lifetime argument. Okay, if you say so. Expected one type argument. Expected one type argument. ESB radio. 97. Array length U8. Yeah, the Zoom one. I'm saying my computer I don't think can encode to YouTube and do Zoom, and I don't think I can have everyone join Zoom on an open call for a stream. I guess I could do the Zoom call and record it and post it later. 124. Expected one type argument. I bet you expected a type argument, didn't you? Is it gonna be... Oh, it needs two type arguments, doesn't it? Because we're not going to guarantee that incoming length and outgoing length are the same. So radio actually needs to be generic over incoming length and outgoing length. Who let me write generic code? And then it's going to complain that N is not payload write from the radio perspective is going to be the incoming len. Wrong number of type arguments, because now I have to undo all of the things that I just did. Expected type arguments. Expected one, yeah. Yes, yes, yes. You might be missing a type parameter n. Cannot find type n. 33. TX grant is going to be incoming len, outgoing len. Okay. We're starting to get down to like reasonable reasonable. And I'm going to go over to my payload header. And I think I'm just going to have some accessor methods. I don't know how you feel about accessor methods, but I think I need them. Yeah, I think you're right, Telus. I think I got this backwards. We'll see, because like as soon as we write the code, if all of a sudden it starts throwing really crazy type errors, then we know that I got it backwards somewhere. So whenever we write the first like actual hardware code application example, we just need to make sure our incoming lengths and our outgoing lengths are different size, because then it will vomit type errors everywhere if like one was 32 and one was 64. So this is like trying to think of bidirectional communication in two parts is like the worst. Pipe. Okay, it appears that I need a pipe method. So this is going to get risky because I'm going to have to look at the pipe index. One. Let's, you know what? Let's just there's probably more elegant ways to do this, but I'm not going to think of them tonight. do. Um. Self dot raw grant pipe peripherals 154. So what I'm doing is trying to. Oh, payload doesn't exist right now, but that's. Oh no, I guess it does. So payload dot pipe. Pipe. This is gonna be payload dot dref. What are we doing? We're transmitting, so it's just dref. Hey, look, it compiles! Yay! I don't think it actually does what we want it to do, but let's celebrate a compile. Give me 1 second. I'm going to drop out. I'll be back in a minute or two. Sorry about that. Had to respond to something real quick. Talis has already pointed out a bunch of problems in my code, so that's good. So let's fix that. We want payload header size ... Because when we deref, we want to only get the payload. We don't want bits of the header because we want to pretend that the header doesn't exist. I also want to add a note to myself. Do not reorder these two items. Well, must not be. Well, I guess they can be reordered here. Doesn't really matter where they are in the struct. They just have to be in this order. Do not change hardware dependent. And you're also making notes about things and stuff. Deref won't work for DMA because it needs the length field and PID no ACK. You are correct. You are correct. You need another method for payload W. You need pub fun. Let's see, this is payload right. So you're going to need a method called DMA pointer. Just going to take an and mute self, and it's going to return a star mutt u8. And it is going to be a self dot grant const fn software header size. Probably making this more complicated than I need to be, but no, this is not what I want. I want that. That probably makes a whole this is no, size is not what I want. Software header size is 2. DMA payload offset is what I want. I want an I size, and I want grant it's smart enough to just do this grant dot offset that? No. Grant as star mut star const u8 as star mut u8 as star const. Do I have like the just dot? Okay, how about self.grant.deref mute as star mut u8? Casting this is probably going to be unsafe. Dot cast u8. Type of this value must be you know what? I've had about as mut pointer. Well, now I figured it out a different way, but expected star pointer. But in fact, I do want to do it the way that you showed me. So yes, you are actually very right. Payload header DMA offset. What do you mean DMA payload offset? Another problem is that you need payload header DMA offset. I think that's what this is. Thank you. As mut punter dot cast u8 dot offset. Okay. Let's not pretend that that's a safe method. Okay, so where was that? That was going to be on peripherals. There was deref. So on transmit, okay, so now I actually need all of these Slices buffer. Oh, you're right. This does not, in fact, need a cast U8. I wonder, can I get around? Nope. I couldn't remember if it's cast or if azimuth pointer. Probably azimuth pointer and offset. Some of these pointer methods are not always unsafe, but yeah. Okay, now I actually need this whole thing for like payload R too. This is maybe not right. Because we... Because we already have... The grant is actually going to need the whole... I may want to wrap new to not take a grant. We'll see once I start messing with this. Because I think we actually need it on the read grant. I don't know if we actually need the header coming in, because you're just going to use the accessor methods for that. Okay. Because we write those afterwards, so we're going to have setters on this one. Grant R, and I think you are actually going to get a const because you're reading from on the way out. Now on the way, grant W, this is all kinds of confusing because the payload R, yeah, is for sending. I think I see what you're saying. I think I actually do need this, I think, actually. No, that's right. Payload, when you read the payload. When you read the payload, you are sending the packet on the radio. The header has already been... We need to write... We need to write the header. The header needs to be there. I think we may actually need 4 different payload types. Because I think we're going to have outload, payload, read, which is not... Can we get away with this being symmetrical? Okay. Let me... Where's my notes? Thinking about payloads. So we have outgoing grant write. We have outgoing and we have incoming. And for each of these, we have grant W and we have grant R. So on grant R W, you fill the header app, then commit. Grant R is going to read the header, set bits, get putter. Incoming is going to not fill the header. It's gonna not fill the header. I don't know how we do stuff like channel, but I guess channel is going to be like a feature. Like, we're not going to be able to send different channels for each message, or at least we can't do that now. We might want to do that in the future. Like, each message can change a channel. So on Grant, we're not going to fill the header. DMA obtain grant, not fill the header. DMA obtain grant, fill the header, fill the payload, then commit. Grant is going to obtain grant, it's late here and I'm having to think through this, so I'm writing notes to myself, so because I'm probably going to stop here in the next like 15-20 minutes. So I'm mostly writing notes to myself so I remember how to pick this back up. Each message has its own pipe, which is the channel. Pipes and channels are different. Pipes are logical addresses, channels are radio properties. Like, channel's the frequency. So I guess maybe it's overloaded. Like, the pipe we are doing where you can do different pipes, but different pipes, I don't think each pipe gets its own radio channel. I don't think. I think I think pipe is a logical digital concept, not like an analog radio concept. Correct me if I'm wrong, though. Obtain grant. Read the header. Set bits. Get pointer. Give to DMA. Release grant on completion. DMA occurs. Incoming, we obtain a grant, do not fill the header. Get pointer, give to DMA. DMA occurs. Get bits, fill the header. Fill the header, release grant, or commit. Grant are probably like obtain grant, read data, header, whatever. Release grant. On incoming, DMA fills length and PID no act, but we need to fill RSSI pipe. Yeah. Yeah. Commit based on len. Based on len. But that's also part of fill the header. So this is actually here. Based on header. Okay. So does this match the interfaces that I have? So let's get rid of my... Okay, let's do a check of payload W. I think these are supposed to be payload R's now. Are they? Do I impl dref for payload R anywhere? Yeah. The name dref is defined multiple times. Well, then let's not do that. Dref mute on 191. Cannot borrow is mutable. Oh, right. We don't get a dref mute for payload R. Cool. Yeah, I think I'm probably going to agree with you. I don't think these are incompatible types. Yeah, we're probably just going to have like two different kinds of constructors or something like that. It's going to be like new from app and new from radio or something like that. Just to make it really clear for myself. But that's why I'm also going through this. So let's start with grant W. So we can ask the user to fill in the header separately. So let's call like new from app. That's reasonable in my opinion. And then we fill in the payload, we fill in the header. We probably need the... Oh, I don't have the commit. The header... Yeah, we're probably going to already have a header that is the right size. So... well, yeah. Maybe we can get away with just self. Commit is going to be self.grant.commit is going to be self.pubfun. What do I call payload size? Is it just going to be payload size? Length. Okay. Payload length. Self.grant payload header length index as usize plus Talis, do you know if the length inside of the payload includes the 2 header bytes? Like, does that include length and PID-NOAC, or is that just the length of payload? The user won't do the new from app. Yeah, it shouldn't really be pub. It should be like, I mean, I need to figure out the visibility. Like, some of these are not going to be safe. New from app should only be creatable from the from the ESB app. Like, yeah. So the user, I say new from app, that just means like from the application side. This means you're using it's new from ESB app basically. But yeah. Okay, so I think this is what we need here. Okay, so obtain the grant, fill the payload. Cool. I mean, they've already selected how they're going to have to select how big it is before they create the radio packet, I suppose. I guess they could commit something less. What if they wanted to commit something less? Talus, they're probably going to want to be able to commit something less, aren't they? They're going to have to commit something less than the size of it. So we might want to up on commit. We might want len. Um, because the header is going to, so like you could shrink the header after the fact, but you can't grow the header after the fact because BBQ won't let you grow the header after the fact. But whatever size you request in the payload header is going to be like the max size of your payload. I think that's the most flexibility that I can give you. Fill the payload, fill the header based on len. Yeah, probably passing this payload header is probably not what I want to do. I probably want to manually set some fields. I probably don't want the whole payload header because the whole payload, like, we don't have the whole payload. Probably what we're just going to have them pass is max, grant, and pipe or something like that. Maybe ack no, pid no ack. I don't know. We'll see. I need to get this done first. I'd rather clean up the API later. This will work now. It might be ugly and easy to get wrong, but I will clean that up later. Okay, then commit. They have the ability to commit. Cool. Grant R from the radio perspective, or payload R from the radio perspective. Obtain the grant. Yes. Maybe I'll have like pub fun get header, because you're probably going to want to access all of these anyway. The headery bits. Does that take ownership of from bytes? Okay. This is going to complain because I'm going to give it a slice and it's going to be like, that's not 4 bytes. You should also change the length on the header on commit. Ooh, that is a good catch. And then Expected struct payload header found parentheses. That's probably up somewhere else. This is probably expected found usize. Where am I getting? Yep, I did need mute self. See, why can't you see that? Grant, obtain the grant, read the header. So you have the ability to get a header from this. I want to set the bits. That's a radio thing. Get pointer. So do I have the ability to get a DMA pointer? I do have the ability to get a DMA pointer. And I need the ability to release. You're always going to release the whole thing. So pub fun release self is just going to be self.grant.release. What do I do? I wonder what I do on BBQ. Oh, interesting. People are pinging me about other interesting things. Stay on focus. Okay, incoming, obtain grant and not fill the header. So we need to have another constructor for payload W. Pub, create, fun, new from radio, where we will need a mute raw grant, which is a frame grant W static and but we don't need to fill in the header because we don't actually know what any of the header values are yet. Wonder if I should just have set methods for all of this. I guess this seems sort of foot gunny. Like I probably should have like a commit from app, commit from new from radio. Yeah, this interface feels a little foot gunny, but let's clean it up later. Famous last words. Alright, this is just self. I don't think we have any invariants to uphold here. Except for the stuff like pipe's going to be totally invalid before you set it, but what are you going to do? DMA, get bits, fill the header. Okay, so we need the ability to set each of the header fields, but we're going to know all of them. Okay, so we have the ability to fill the header, commit based on len. So we can commit based on the payload len, but I don't want to have to I'm gonna need like a commit no len because, or just like no shrinkage, because otherwise I'm gonna have to provide the value twice. But whatever, that's okay. Maybe I'll have like an option commit here or something like that. Whatever. Whatever. This can probably be refactored at some point. I guess commit all is just gonna do payload and bytes, not including the frame header. Okay, cool. Yeah, that's fine. Okay, so I think fill the header we have, because we have the ability to update header and commit based on len. Cool. Grant R, we need to be able to attain a grant. See, but obtain grant, read the header. Set bits. Okay, but on the other side, it's always going to have the header already in there. So like the header is always valid for payload R, which is why we don't have to write it, because it was filled out by the other side. It's the job of the writer to fill the header. Read data, yeah, release grant. Okay, I think this is actually all we need. I think the grant interfaces are complete, but a little ugly. Good enough for now. Okay. Oh, right. I can't. Okay, so that's at least pushed. So if something terrible happens, you have the code. All right, I'm gonna take another quick 5-minute break, and then I'm gonna take one stab at integrating this end to end with all the grants and all of the stuff we need. If it goes terribly, I'm going to bail again. But if it goes well, I'm going to commit that, and maybe Talus can either do the merge or the rebase, or even just test it on hardware if you have the hardware set up already. So I'm going to take like a 5-minute break stretch. I'm going to come back, try and stab for like 20 minutes, see how it goes. I don't even know if anyone's still watching this, but this one's going to be a long one. There's still 6 of you here. Hey, thanks for sticking around for a very long stream. Let's see if I can make it worth it. All right, be back in a bit. Okay, last ditch effort. Here we go. Let me get some stuff ready first. Okay, let's see if I have any messages. Nope, stream is quiet. I think everyone has fallen asleep. Excellent. Time to implement code. Ooh. My soundproofing mattress. And when I say soundproofing, I mean this is the only place in my house where this mattress fits. Oops. Yeah, we had some guests come over, so we had a spare mattress for them, and it's literally the only time we've ever used it. So it's probably a bad choice to just buy it. We should have, like just put them in a hotel or something. Okay, let's see if we can't wire this all up. I think we've got everything we need. So let's look here. So I should probably break this up into things, but hey. We have the ability to split. We have the app and the IRQ. We have the ability to get grants. Oh, you know what? I haven't implemented anything about anyone getting grants. Oh, goodness. I am much further than I thought I was. Well, hopefully this is just a little bit of plumbing. So we'll see how quickly this goes. Okay, let's start on the app side. You know what? Let's do... See, you can't hear my audio, so I'm going to play some music because I want to play some music because it's late and I need to keep myself going. It's 2 in the morning. I don't know why I'm still going. I need to stop strictly at like 12:30 or like 12:45 from now on, but I really want to get this done. So let's... I guess this is really going to be peripherals. What would be a good name for these parts? I'm going to have... I'm going to like restructure everything, and it's going to make Talus sad because it's going to... Sorry, Talus. This is the point where I made merging sad. Alright, I'm going to share my music with you because I'm not going to be very talkative, so I'm going to keep it here. So hopefully we'll see if this is reasonable. So you're going to listen to me over some music because I'm not going to be too talkative for the rest of the part. Because I'm going to try and focus on getting this done. So hopefully we can follow along. Peripherals. $131. Cannot find ESB app in this scope. Buffer.rs. Buffer RS. Field radio obstruct IRQ. ESB IRQ. Why does the buffer need to know? Oh, it needs it for the constructor. Yeah, I can make this a complicated constructor, or I could just give access to it. We'll see. Maybe we'll make a constructor later. Payload.rs. Raw grant does not need to be mutable on 144. Okay, so now in the app side of things, I thought on IRQ I had an impl block. Yeah, let's steal this. I had my notes that will tell me what I thought the interface should be. So we might need an init or something like that. Enable ESB or something. Yeah, I wonder if we need like control messages going back and forth, or if it's just is init already, or maybe we need to init it before we... We decided to do the auto send version, so pending the radio or something like that should be fine. We're gonna need to use crate, payload, right. We might want to hide this interface from the user, but I think making it pub crate is fine for now. Payload is outgoing LAN. So we'll need payload W and payload header. Like this should probably be a, well, no, I guess I don't know where else this would live, but equals max payload as USI, or let's just do we're gonna do self.prod to radio.grant max payload plus payload header size, and this is going to be a result. Result, use core result. Lib probably in progress queue empty, queue full. App. Header size is private. Payload. Start send. I think when do people need to tell me what the... I guess we can ask them to just give us the... length. I guess complete send is a method on the message, and the message should pen the radio. But the message should only pen the radio from the app. Interesting. That seems really foot gunny. I wonder if I should just wrap that in a new type. Yeah, I guess you're gonna have to have a start TX or something like that. So I guess I'm just going to keep it with init. So I guess for now you have to call no auto send yet. Pub function. Now I'm looking up the docs for Cortex-M penned because I can never remember what the docs for this are. Documentation. Invic pen. Do we rely on Cortex-M? I think the pack re-exports it. How do we expose the pack here? We have two copies of interrupt. That's weird. this is all the ESB app has to do. So let's do the same thing on the other side. So when we are in IRQ, we're gonna need oh no, the app still has a few more methods. Okay, so we have the ability to read a packet, and then release is gonna be release, so we don't have to touch that. Okay, so now app should be done, I think. So now I should just do IRQ, and man, it is late. I'm not really gonna test this, but yeah, let's see if I could do the stub of the IRQ side. So the IRQ side is gonna have to no, I'm done. Oh goodness. Okay. It's late. Sorry, Talis. This is as far as I got, but hopefully it should be pretty clear what to do from now. And if I don't get back to it, then I will pick it up tomorrow, I guess. Okay. Well, hopefully this was useful. Thanks to so if you're still here, you're one of the 6 people that are still here, then I super appreciate it. And thank you for watching. And hopefully this was very useful. And I'll see you again on the next stream. Thank you, everyone.